Good afternoon. Thank you for taking the time out of your busy schedule today to join us for this review of the 2021 London Plan. I'm Phil O'Loughlin. I'm the Divisional Head of IES Consultancy's arm for the UK, and I'm joined today by my colleague Hashad Joshi, who is the CFD Consultancy Manager. Later on, Hashad will take you through the requirements and methods of using CFD to ensure the requirements for pedestrian comfort are met. So say hello, Hashad.
Good afternoon, everyone. I hope you're doing well.
And we've also got with us Eric Roberts, who is ably helping us in the background, mediating the questions and making sure everything moves along smoothly. So say hello, Eric, please.
Hi, Phil. Hi, everybody. As Phil said, I'm looking after your questions. We're going to do a question and answer session at the end of this presentation. So if you have got any questions, just put them in the questions box and we will do our best to answer some of them.
Thanks, Eric. Okay, so let's get going. Before we dive into the plan in detail, I'd just like to take the opportunity to give you some background to the IES Consultancy Team. Many of you are familiar with the VE and the other user-friendly products offered by IES, but maybe not so much our team of consultants. The consultancy team sit in a complementary role to the software to assist our clients with their project as required. We have teams located around all corners of the world and hold a wealth of experience between us in terms of operational and normalized energy optimization, comfort assessments, daylight and sunlight analysis, and CFD studies. So looking at the plan, let's start with an overview. This will aid us to understand why we're interested and what its origins are. The London Plan represents a development strategy for the Greater London area and is written by the Mayor of London and in turn published by the Greater London Authority. The regional planning document was first published in final form on the 10th of February 2004. Since then, we have seen tweaks and amendments to it along the way. The new 2021 London Plan came into force 2nd of March 2021. It is intended to be used as a framework for how London will develop over the next 20 to 25 years and challenges applicants and their respective design teams to really focus their minds onto the strategically identified issues in hand, not least the climate emergency. A suite of policy guidance documents accompanies the plan to provide greater detail to the applicants on how to conform with the requirements. It necessitates the local plans prepared by the boroughs to be in general conformity with the main London Plan and its policy guides. Decisions on planning applications by local planning authorities and the Mayor will be strongly influenced by adherence to it. As I mentioned, the plan is intended to invoke a significant shift in thinking. But don't take my word for it. Here is a recent quote from the Mayor of London, Sadiq Khan. The new London Plan marks a break with previous London plans, represents a step change in our approach and serves as a blueprint for the future development and sustainable, inclusive growth of our city. I might just mention here that I was very pleased to see he got re-elected and it saved me having to change this slide. The structure of the new plan has changed significantly since its previous 2016 incarnation, which had 8 policy chapters. We now have 12 policy chapters. We, as thermal modelers and design influencers, are particularly interested in those laid out in chapters 3, Design. This is designated with a D in all sub-policies, so D1, D2, D3, etc. The other chapter of significant interest is chapter 9, Sustainable Infrastructure, which intuitively has its sub-policies designated with SI. I will not concentrate on the other 10 chapters in this presentation and focus on 3 and 9. We will then pay particular attention to the less familiar and newly introduced requirements within said chapters. So let's look at chapter 3, Design first. From review and the experience we have to date, the intention of this chapter is to drive us towards a design-led approach rather than the previous compliance-led approaches. The intention being to achieve indoor and outdoor environments that are comfortable, environmentally sensitive, and appealing for people to make use of them. This next section of the presentation graphically follows the approach shown in this example slide. On the left of the screen, you will see the policies in the dark blue circle. In the center, and the sub-policies orbiting around those in the circles in the lighter colours. On the right-hand side of the screen, you'll see a rectangle that contains the various modelling activities that consultants are able to assist the design team with. I will expand on these duties later in the presentation and will be focusing on some of the detail on particular aspects as we go through, paying particular attention to requirements that we have not previously had to pay too much mind to, or we've not even been required to look at. D1 deals with London's form, character and capacity for growth. D2 deals with infrastructure requirements for sustainable densities. I'm not going to dwell on these and move straight on to D3. D3 advocates a design-led approach to make the best use of land and promote developments that are well connected to jobs, services, infrastructures and amenities by public transport, walking and cycling. The policy is intended to encourage the design of a safe and secure, inclusive environment that is attractive both indoors and outdoors, offering comfort and invitation for people to use. It is also intended to help prevent the impact of noise and poor air quality. High sustainability standards are taken into account within the principles of achieving a circular economy. D4, delivering good design, focuses on design analysis and development certainty. It advocates the use of various digital modelling techniques as part of a wide range of design and presentation methods. The intention is that these can be used as part of the plan making process to assess growth options and the form of development. It challenges the designers to provide the necessary technical information accompanied by relevant design codes and thus ensuring exemplary design standards are carried through the planning process to completion. I won't go into D5, which is a policy based around inclusive design, but move swiftly on to D6, which is housing quality and standards. D6 requires that housing developments should be of a high quality and provide adequately sized rooms with comfortable and functional layouts. It encourages the designers to provide sufficient daylight and sunlight to new and surrounding houses whilst avoiding overheating, minimising overshadowing and maximising the usability of the outside amenity spaces. Policy D7 deals with accessible housing. Again, in terms of thermal modelling, this is not an area I am going to dwell on. D8 encourages us to explore the opportunities to create new public realms. The policy is intended to inspire the design teams to ensure the appropriate shade, shelter, seating, and where possible, areas of direct sunlight are provided with other microclimate considerations, including temperature and wind, to be taken into account in order to encourage people to spend time in a certain place. Again, I'll draw your attention to the rectangle on the right-hand side, which indicates the modelling services that can complement and assist in these requirements. D9 specifically deals with tall buildings. The policy requires applicants to ensure that the building does not cause adverse reflected glare and should be designed to minimise light pollution from internal and external lighting. The environment impact also must be considered in terms of wind, daylight, sunlight penetration and temperature conditions around the building and neighbourhood. The air movement around the buildings and the displacement of pollution should also be considered. We move on now to Chapter 9, Sustainable Infrastructure. The plan has significantly updated for sustainable and energy targets for new buildings. In the 2016 version, we had Chapter 5, London's Response to Climate Change, and have already met the energy hierarchy through this. Chapter 5 has now been replaced by Chapter 9, Sustainable Infrastructure. Again, I am not going to dwell on the policy clauses that do not directly involve the duties we, as building physicists, can help with. So I'm going to jump right through to SI2, minimising greenhouse gas emissions. SI2 mandates the major developments should be net zero carbon. This means reducing greenhouse gas emissions in operation and minimising both annual and peak energy demand in accordance with an enhanced energy hierarchy. As I mentioned earlier, we've already met the lean, clean, green triangle, and this has been bolstered by the introduction of the Be Seen element, which looks towards the building in operation. Be Seen requires the applicant to monitor, verify, and report on energy performance during the first 5 years of the building's occupation. I'll come back to Be Seen in more detail later in this presentation, as it is a significant change in our duties and requires a significant amount of thought and preparation. In addition to the requirement to consider operational energy, there is also a requirement for major developments to have a minimum on-site reduction of at least 35% beyond building regulations. Residential developments should achieve 10% and non-residential developments should achieve 15% through energy efficiency measures, with any deficiencies being made up through a variety of planner-agreed measures when the case of the net zero carbon target cannot be achieved. Whole life cycle carbon emission assessments are required for development proposals referable to the Mayor. Furthermore, the plan requires that major non-referable developments should calculate the unregulated emissions, and applicants are encouraged to undertake whole life cycle carbon assessments as well. Moving on to policy SI4, which dictates the applicant to deal with the management of heat risk. Any proposals should minimise adverse effects on the urban heat island through design layout, orientation, materials, and the incorporation of green infrastructure. Major developments must demonstrate through the aforementioned energy strategy that they will reduce the potential for internal overheating and reliance on air conditioning systems in accordance with a refined version of the cooling hierarchy which we were introduced to in the 2016 plan. So, having met the policies of interest to the thermal modelling fraternity, we'll now briefly run through some of the services that we are more familiar with, and then move on to a little more depth to the services that we are less tuned into. I will not dwell on the former, but provide more detail on the latter as we go. Through early stage modelling, we can help to optimise site layouts and the building design to reduce the risk of overheating. We can take a look at the impact and on development proposals to ensure we minimise the adverse effects of the urban heat island, and using CFD, which Hashad will discuss further shortly, ensure pedestrian comfort is well considered. As the project develops through the REBA stages, from pre-assessment through the actual planning application submission and then to post-construction, we can use the software tools available to us to carry out automated whole life cycle assessments that help calculate and reduce the environmental impact of the buildings and infrastructure provided as required by policy SI2. And with respect to SI4, managing heat risk, through early engagement, the modelling team can assist with optimising the site layout to reduce the amount of heat entering the building by assessing orientation, shading, and fenestration choices. At concept stage, through close engagement with the entire design team, modelling can be used to investigate the provision of passive measures to control overheating alongside mechanical ventilation and ultimately low energy cooling if this should become necessary. I will return later to the question of BScene energy assessment. However, as I mentioned, there is still an obligation to investigate how to gain on-site reductions of at least 35% beyond building regulations for major schemes. Close collaboration between the modellers and the design team will ensure the most suitable, economic and sustainably joined up solutions can be designed into the scheme. Clients should be encouraged to allow for an iterative process to enable the modelling team to investigate and help optimise the ultimate design solution to ensure a successful outcome. In order to meet the requirements of D3, we can use modelling techniques to assess the comfort of pedestrians within the environment with regard to sunlight, shade, wind, and shelter from rain. Housing development proposals can quickly be assessed to ensure they meet the auspices of D6 to provide sufficient daylight and sunlight to the new and surrounding houses whilst avoiding overheating. And to meet the requirements of D8, these sunlight and daylight assessments can be used to ensure direct sunlight is available to the populace for their enjoyment. I'd now like to ask Hashad to give us a little more in-depth detail of how we use CFD to assess pedestrian comfort.
Thank you, Phil. Pedestrian comfort is covered under different policies like D4 and D8. This is achieved by an outdoor microclimate assessment service that's offered by IES. This essentially is a comprehensive service that goes beyond doing the analysis in the traditional ways. It is an encompassing analysis that covers all aspects of outdoor comfort, like wind and sunlight together, to give an assessment that is more robust in helping you design the outdoor spaces much better. Like I said, it has the two components to it. Let's look at the first component now, which is the solar radiation analysis. So the first part of the analysis is a solar radiation analysis. So we will look at and determine the areas of interest on the site, and we will run a radiance type solar analysis to determine the level amount of actual solar radiation being received at different points for every daylight hour. This assessment will take into account all the different shading and surface property factors on the development. So it will take into account things like the reflectivity of any walls, the transmittance of any translucent shading devices, and so on. So it's a fairly comprehensive analysis, and it will determine the mean radiant temperature at every point in the area of interest. Now, this mean radiant temperature is also determined in terms of where the people will be. So it essentially is not just a number calculated on a single plane. It's a spatial average taken from sort of the total height of the person to get a better view of the analysis. The next component in the simulations is the wind component. Wind is the traditional one associated with a pedestrian comfort analysis. In this analysis, as has been done traditionally, this is a virtual wind tunnel analysis. So we create the full model of the site, including all the elements, and blow wind over the site in the CFD program. The wind can be blown over it in 16 wind directions typically. The City of London wind microclimate guidelines require 36 wind directions, so we can manage that as well. Then, using a suitable weather file, we are now calculating the local airspeeds that will be achieved throughout the year. So we are estimating the local airspeeds that are achieved at every single location, and we can then do a statistical analysis on the wind on its own. One of the way this is carried out is the Lawson's pedestrian comfort criterion. And here's an example of the comfort component of it. It essentially states gives us a threshold wind speed that we will feel fairly comfortable as long as the airspeed around us doesn't exceed these numbers. So, for example, if you are designing an outdoor space that is to be used for a long-term sitting, like a park in the middle of your development, or you're looking to create a leisurely walking, like a dog walking park or a jogging path, you would want to meet the 8 meters per second criterion. What the criterion says is that we should not exceed the wind speeds for more than 5% of the year. So you have for 95% of the year, the air speeds within the development or within these designated areas have to be below this threshold wind speed. So an annual analysis done in the way we do it helps to establish whether these locations will be usable in these way or not. Once we've done the solar analysis and we've done the wind analysis, we are then able to combine them together to create the full pedestrian comfort analysis. In this, we take the results from the solar radiation analysis, we take the results from the wind analysis, we include even the human physiological factors like metabolic rate, clothing level, so depending on the location. So like I said, we were looking at a jogging track, so we can have an appropriate metabolic rate for that area, appropriate clothing level for that area. If it's a park, we can have the clothing level for that area based on the season. So in summer, you would have a light level of clothing. In winter, you would have typically a thick jacket on the people, and the clothing level will be determined that way. And using a suitable weather file to get things like ambient temperature, the humidity levels, we combine that all to calculate what's called the Universal Thermal Comfort Index. Now, this is a very long, winding definition for it. Essentially, what it is trying to look at is a heat thermal stress. It has got, various levels. It gives a temperature-like value, so that we can look at different levels of heat stress. The level kind of goes from plus 46 degrees to the kind of minus 46 degrees. And even the no thermal stress, or what's called a comfortable period, is goes from 9 to 26 degrees. Essentially, you can look at the thermal stress in terms of an overall feeling of comfort you might get depending on the season and clothing. For example, on a cold winter's day, the temperature might be close to 3 or 4 degrees, but if it is nicely sunny, there is no wind, you would still not mind sitting outside and having a cup of coffee. Same goes for summer. You may have a heat wave where it's almost 25, 30 degrees, but if there is a slight cool breeze going on, you will still want to stay outside. So these are the kind of extremes that are covered by the thermal stress range from 9 to 26 degrees. And you would want to have a development that promotes this range. The beauty of this analysis is it's not just limited to doing it over here. It can be done anywhere in the world, not just for London. What it ensures is that you are trying to create a pleasant outdoor space. And outdoor spaces are now very much important given all the things that are going on in the world and the social distancing and physical distancing that we need to maintain between people and have as many people enjoying a space as possible. So this type of analysis, it's not just an analysis that helps you meet the policy guidelines. It actually has a quantifiable economic benefit. You can sell the space by proving to the prospective tenants that we've designed this space to be a cafe. We have designed, there are let's say there are screens and we've put trees and everything, and here's an analysis which shows that actually these are going to be very effective in keeping the space in a comfortable position depending on the season. It's not going to maintain it all same temperature, but the space is going to be usable for a longer time, and it helps boost the economic benefit. If we are designing a lunch space for a high-rise tower, you can prove that you've designed it in such a way that it, the wind's not there, it's comfortable, and people can use it. It can help you improve the value of the property. And overall, when people are outside, they tend to meet each other, and as it says in the last line, it really helps to reinforce the community bond. So overall, the analysis, I would say, to summarize, it's an analysis that we provide that not just helps you meet the policies, it also actually has deep economic benefits from it. I'm going to hand it over back to Phil to continue with the rest of the presentation.
Well, thanks for that, Harshad. And I'm sure, as you mentioned there, that pedestrian comfort, external pedestrian comfort, is going to be very much at the front of many people's minds in the current climate and strange times that we're living through. Okay, so moving back now to the little deeper dig into Be Seen. I'm going to just move back through the energy triangle and add some more meat to it. Policy SI2 mandates us to move through this hierarchy. As mentioned, the Be Seen, Be Lean, Be Clean, Be Green offset triangle is likely familiar to many of you who have worked on previous London Plan policy compliance. This goes some way towards the intention of reducing greenhouse gas emissions. It is the introduction of Be Seen that has greatly and positively, in my opinion, enhanced the energy model and should serve to significantly reduce the commonly perceived performance gap between the normalised energy from building regulation calculations and actual energy performance in use. To date, policymakers have chosen not to invest in operational benchmarking to drive the carbon intensity downwards, but have stuck to the traditional area of building regulation assessments. As we move through a recognition of the climate emergency, I would hope this will change for the good. In Australia, the Neighbours Rating Scheme has successfully demonstrated that the use of operational ratings can motivate management to cut energy use substantially and progressively. Through the Better Building Partnership, Neighbours UK has now been facilitated and provides a positive move towards a narrowed performance gap, but does require significantly enhanced effort by the whole design team. However, this is not the subject matter here. At this juncture, the pathway towards providing the Be Seen requirement is still unsettled. We understand that the finalised policy guidance document will not be available until the summer of this year. That said, there is a consultation document available which we can now draw some pointers from as to how the likely requirements will go. On the 17th of November 2020, the London Plan team and colleagues held an event for all to set out the content of the Be Seen energy monitoring guidance. You can find this by a simple Google search to see that document and the webinars that went with it. During the planning stage, there is a requirement to develop accurate estimates of the likely energy consumption of the building proposed, along with estimates of carbon emissions. The estimated carbon shortfall and proposed carbon offset should also be assessed. In order to do this, the modelers need to produce a significantly enhanced model to investigate the operational energy in use. This model will need to include elements that were previously not assessed under building regulation assessments, such as external lighting, lift energy, and realistic equipment loads. We would also suggest that the use of seasonal efficiencies are likely to prove inadequate for this type of assessment, and a detailed HVAC network should be developed at the earliest design stage possible to ensure realistic part load efficiencies are accounted for effectively. As I say, the guidance on this policy is not finalised, but we understand that developers are encouraged to consider and implement additional best practice industry guidelines through an enhanced model, adopting the principles in guidance such as CIBSE TM54 and the recently issued TM60 series, relating to operational performance guidance, or perhaps the neighbour's guidance will provide a suitable indicator of the building performance KPIs required. We have been working on neighbours projects and have found this type of study will serve as a solid foundation for the design team and significantly aid in decision making to ensure the project adopts as low an energy and carbon impact in operation as possible. However, the effort is substantial. In all our operational energy in use studies to date, regardless of the framework we are using, where possible, we have enhanced the models with dynamic features to provide for a better prediction of energy in use. Daylight dimming, for example, rather than just applying a reduction factor by linking the lighting to a radiance sensor, we can model the behavior of the daily lighting energy consumption more realistically through the seasons. We found the impact of daylight dimming versus daylight switching, for example, on one project to be quite remarkable and changed the direction of the electrical design in this respect. Similarly, outside lighting can be simulated for operation with a dusk until dawn photoelectric daylight sensor to ensure that the operation of the lighting is properly accounted for. The guidance sets out the concept of reportable units. It categorizes how to report data. There is to be an appendix in the document. Currently, in the draft consultation document, it's Appendix 2, which provides more detail on this. But basically, it is required to report against various milestones and KPIs, such as development information, energy use, district heating import, predicted and actual DECs, renewable energy data, energy storage equipment and its capacity, estimates of carbon emissions, estimated carbon shortfalls, agreed carbon offset with the local planning authority. The required in-use KPIs can mostly be extracted from the Vista results from your model, provided it has been set up carefully and is adequately metered to do so. On completion of the building phase and moving into occupancy, the model can be repurposed and calibrated to become a true digital twin. The plan moves us towards zero carbon development, requiring comprehensive monitoring of energy demand and carbon emissions. We at IES pass this over to our iScan team, who spend the time harmonizing the important metering and carrying out calibration of the building. The plan requires reporting via an online portal to the Mayor's office for at least 5 years to enable the GLA to identify good practice and report on the operational performance of new developments in London. A well-calibrated design stage operational energy model will comfortably facilitate this requirement. In order to achieve this, careful planning with respect to zoning and metering is of the utmost importance. The VE users out there will hopefully have got to grips with the metering facilities provided in Apache Sim to meet this need. So, in summary, we've now reviewed some of the policies and discussed how the various modelling duties thermal modelers can assist applicants in meeting the requirements. The duties discussed can be seen circling the plan as a whole here. I do hope this webinar proved useful and hopefully insightful. We at IES Consultancy would be more than happy to discuss any specific requirements you may have, be it mentoring, assistance on in-use studies, or simply helping you flatten out those peaks of project demand by bringing our team of experienced consultants to your disposal. I'd now like to ask Eric Roberts, our moderator, who has been busy assisting us, to put some of the questions that have been raised during the presentation to us for consideration. So what have we got, Eric?
All right, thanks, Phil. Hi, everyone. Got the ones that have come in, Phil, should be able to answer. You made mention of the requirements to calculate and upload KPIs to the GLA website. This sounds time consuming and costly at the planning stage. Can we just use rules of thumb at this time?
Right. Well, I mean, the option, and this is your choice, I suppose, as the design team. Confirmation of the data has to be provided at the planning stage, and the proposed metering details need to be provided as well. At the completion of the build, and you know, you have to provide particular assurances to the planners that all the metering is in place and has been calibrated to see the building in use. So if your energy in use then differs substantially from your initial proposals, you're going to be held to account as to how or why this has happened. And we understand this is going to be enshrined into a legal requirement to enable the GLA to have like enforcement measures, either through the the planning condition schedule or the section 6 or whatever it is. And any shortfall that you have in your application, you will have to justify, or the design team or the applicant will have to justify to them. So, you know, the risk of getting a disparity between your results and the actual findings are there to be provided. The risks legally are there for us to all see. So I mean, I would suggest that you would want to as an accurate prediction as you can get.
Cool. Thanks, Phil. Question: what is the policy applicable to? I guess what sort of development, size of developments?
Which it's all major developments have to be reported. I think the residential major development is over 10 units, 10 domestic units, and then I think the non-domestic is over 1,000 square meters. I might just need to check that, but I'm pretty sure that's what the policy is applicable to. They're sort of encouraging the use of the plan as a guide, at least for any significant scheme.
So you've talked a bit about some of the HVAC model in there. So a question: why can't we just use seasonal efficiencies? Why we need to look at part load efficiencies?
Well, you could use seasonal efficiencies in your sort of concept modelling early on. I suppose a lot depends on your confidence in the scheme's progression. If you have some doubts as to whether the scheme may progress, then you may choose to take a very minimal approach to the amount of effort you put into either your model or just your rules of thumb, if that's the route you're going to go down. If you then at sort of REBA stage 2, 3, you want a very rough and ready concept model. You could use seasonal efficiencies to give you an indication of where your energy is going to be at. The problem is that as your scheme develops, you're going to need to move into detailed design, and then you really do need to, like in our case, use an Apache HVAC network to better assess the energy in use on a daily basis, and seasonal efficiencies just won't cut that at all. You've got to put in your part load performance curves. So if you've got confidence that your scheme is going to go forward, then opting to do a HVAC network as soon as possible makes sense, because otherwise your model that was based on seasonal efficiencies would become redundant. So it is possible to use seasonal efficiencies, but again, as I say, it depends on your confidence in the scheme, your client's confidence in the scheme, and the fee they're prepared to agree to at that particular time. Will enable you to make decisions on which is the best way forward.
Cool. We've got a couple of questions. They link in together, really, Phil. So we've got question asking: is it mandatory to complete a TM54 operational energy assessment, and will this determine the net zero requirement? Is this still based on Part L net zero? And similar sort of add-on question to that one: is there a requirement to calculate unregulated energy, and how should we do that?
Right. TM54 in itself it's a 2013 document, and some of the, I mean, it's only guidance, of course, and some of the recommendations in there are somewhat outdated with modern techniques and modern thinking. For example, the methodology for calculating lift energy detailed in TM54 have actually been superseded and fairly significantly changed in SIBSE Guide D. So the framework of TM54 is great, but I would definitely suggest that it's used as a basis of assessment as opposed to a rigid way of doing things, because it only offers a possible route through an assessment. So you really need to ask yourself, how is my building going to look in operation? Because at the end of the day, there's nowhere to hide your operational energy when it's being reported on from years 1 to 5. So there is no mandate for you to do a TM54 study per se, but you are obliged to try and provide a decent estimate of the likely operational energy in use. Of course, it's a lot of offices, for example, are speculative. Who knows what's going to go on in those spaces? And if you had this disparity between your submitted design stage predicted energy use and the building in use, if you've created your model in such a way that you can see the meters as predicted and the meters in use, and you've got a client in those offices who is either really hammering the energy or conversely is very rarely present, either way you'd have a disparity, then you have a tool to say this is why this has happened. What you definitely need to do is ensure that you've covered yourself for any kind of questions coming your way, and avoiding any sort of disputes that way that could well has the potential to become quite unpleasant, I should imagine.
Yeah, I think I'd just like to add on to that as well. TM54 is currently under review by working group at SIBSE, and will be updated, not being rewritten as a new document, but just being updated from where it is, because obviously that dates back to like 2013, I think it is. So it's it's just going to go through a slight update process. So I haven't got any dates of when that would be is due for release, but it is in progress. Just got a question about whole life cycle analysis. Just asking, is it the responsibility of the building physicist to provide whole life cycle assessment? And do IES offer this? It's not necessarily the responsibility of the building physicist. It could be down to the sustainability engineer. It completely depends on whose remit that falls under within the project. In terms of IES offering, we offer a direct link in from your IES VE model into one-click LCA, so you can get your model, export that straight into one-click. And obviously, as Phil said, if you've done all your energy calculations as well, not only will it pull the building and all its measurements across, it will pull all of the energy data in there as well as part of that. And yes, if you contact us regarding that and training, yes, we can help you in terms of that. Karshad, we've got a few questions on CFD about that within conducting pedestrian analysis within the VE, as well as modelling building forms and vegetation within that. Would you like to address those for us, please?
Yes. So with respect to vegetation, the analysis we provide does take vegetation into account. So we can have the vegetation as a barrier to the wind, as well as shading device for the solar radiation analysis, and it can have appropriate properties of emissivity applied to it to produce emissivity, reflectivity applied to it to give it the fullest effect on its capacity to shade a location. So yes, vegetation is included in the analysis in quite a bit detail, maybe not the detail as in the leaves and stuff, but enough detail to make a difference of having it and not having it. The ISV software does not provide the pedestrian comfort analysis within itself. This is an over-the-top service that IES provide. Most of the ISV components deal with the internal parts of any building. This is overall an external analysis that's carried out outside the building. So it's part of a service rather than part of the ISV package.
Thanks for that, Harshad. I think we're coming up to our time there, so I think we've just got time for really one more question. So just on policy S12, Phil, what does energy efficiency measures refer to specifically? As it's a fairly broad term.
It is a broad term. Energy efficiency measures are anything that you can really squeeze into the be lean element of your triangle. So if anybody's done these kind of assessments, the measures can be right from sort of building fabric improvements right through to enhanced building services or lighting, measures that you can make that are above and beyond the sort of baseline building model. I mean, not very often people use the notional building as the baseline. So improvements that you make on that can represent that energy efficiency improvement.
Yeah. All right. Thanks for that, Phil. I'm afraid that's about all we can fit in the hour that we've got for this presentation. There's a lot of questions we haven't been able to get to. There's a lot of people who have got questions on this. I'm very sorry we haven't been able to get to yours. But if you have specific questions, anything we could help you with, please feel free to contact either myself, Eric Roberts, or Phil, and we would be happy to try and see if we can help you out. From myself, thank you all for attending. I had a lot of people on today, so there's obviously a lot of interest in this subject area. From myself, thank you very much, and back to you, Phil.
Yeah, just echoing Eric's comments there. Thank you all very much for your valuable time today. I'll wish you a pleasant afternoon, and thank you very much for your time.